let's continue our chapter 2. This section is relations and functions. So let's look at the definition. A function is a relationship in which each element of domain is the input and usually is the x, correspond to one and only one element of the range. The range is the output, so basically you have input and then you have output. Input usually is the x and output is the y. So if you have only one and only one of element of range. Let's look at example here. Determine whether y is a function of x. So I have y squared minus x squared equal to 4. I'm going to solve for y. So y squared would be x squared minus 4. I'm going to take root both sides. So y would equal to plus or minus square root of x squared minus 4. Alright, so let's look at this. So let x equal to 0. So if x equal to 0, y could be, I have to have plus here. Yeah. If x equal to 0, y could be plus or minus 2. Alright, so I have one x but I have two y. So this is not a function because by the relationship, each element of domain, which is x is my domain, which is 0, will correspond to one and only one element of range, but it corresponds to two number here, plus or minus 2. So this is not a function. Alright, another test you can do is called vertical line test. So let's say if you have a circle, you don't have room here, but if you have a circle, if you draw a vertical line and if cut the graph more than one, it's not a function. So if you draw a line here anywhere, you can have to cut here, so it's not a function. Alright, so you can do vertical line test as well. The next one is, what is this? The next one is find the domain of a function. Domain here is an x. So let's look at the function f of x is equal to 2x over x squared minus 1. So we want to find the value of x. So from here, we don't want the denominator to be 0. So we don't want x squared minus 1. We don't want it to equal to 0. Which means x squared cannot equal to 1, which implies x cannot equal to plus or minus 1. Because if x equal to 1, you have 0 on the denominator, same as negative 1. So it can be anything but plus or minus 1. Look at the second one. G of x is equal to square root of x minus 3 over x plus 2. So first thing, we don't want denominator to be 0. So x cannot be negative 2. Because if x equal to negative 2, denominator is 0. Also, we don't want any number in radical to be negative because negative is not a real number. So x has to be greater than or equal to 3. It can be 3 because if 3 minus 3 is 0, 0 is okay to be on the numerator. So we don't want it to be anything less than 3. So if you combine these two together, the answer would be x cannot greater than 3. It has to be greater than 3, I'm sorry. X has to be greater than 3 to satisfy this function. So that's the domain. X has to be greater than 3. Now let's look at the next two examples. Find the domain and range, and they give you the graph. Domain is an interval of x. Range is an interval of y. So look at the domain. Look at x. I have a spot here, a complete circle, and this one. So look at the horizontal line. So the domain is going to be from -1, including -1. So from -1, including the -1, look at the horizontal, up to 3, because it's closed circle, so including 3. Now range, you look at up and down. Alright, so it's going to start from here, which is -2, up and down. So it's going to start from -2 up to 4, not above 4, including 4. So that would be your range. Now let's look at the next graph. Domain, again domain is the horizontal. Alright, horizontal, you start from -infinity up to this point here, which is x is 4, including 4. Now range, think of up and down. Alright, the lowest point here is -1, including -1. Up and down, so it's up to 3, including 3. So that would be your range. Alright, let's see more example. Hi, let's continue our next section, 2.5, property of a functions. Let's look at the first one. F is called an increasing function on an interval AB if x1 less than x2 imply f of x1 less than f of x2. So let's look at the graph just to understand this definition. So I have an interval AB, let's say right here, and x1 is less than x2. As you can see, x1 is on the left hand side of x2. So x1 is less than x2. Then imply f of x1. Let's say if my f of x1 is right here, this is f of x1. So f of x1 have to be less than f of x2. So my f of x2 have to be above this point here. So it has to be somewhere up here or higher. So f of x2. So your graph is increasing. So that's increasing. Next one, f is called a decreased function on an interval AB if x1 less than x2, my x1 is less than x2, and f of x1 have to be greater than f of x2. Let's say my f of x1 is over here. So my f of x2 has to be below that, lower. So it's somewhere here. So it's decreasing. Right? Next definition, f is a constant on an interval AB if x1 less than x2, x1 less than x2, f of x1. Let's say if my f of x1 is right here, my f of x2 has to be equal to f of x1. So it has to be the same level. So they're equal. So that's constant. All right. Now let's look at the next example. I have a graph here. Let's fill out all this definition. Domain is the x interval. Look at the horizontal. This graph go infinitely and go down infinitely. So the domain, the x interval is -infinity to +infinity. Range, look at the vertical, up and down. So it go down infinitely. So it's from -infinity and go up infinitely. So go to +infinity. X-intercept, so it's intercept here as -4, 0, and 4. That's your x-intercept. Your y-intercept where it's cross y-axis, so it's only cross right here, which is 0. Relative max is mean the maximum around that area. So my relative max is 2, 3. Relative mean is the minimum point in that graph, in that area. So -2 and -3. Absolute max it keep on going infinitely, so we don't have absolute max. Absolute mean the arrow go down infinitely, so we don't have absolute mean. Alright, let's look at our odd and even function. Alright, let's look at our next section. Even function. If you have f of x equal to f of negative x, then it's an even function. So you need to prove this. Odd function is mean if you have f of negative x is equal to negative f of x. So let's look at our first example. I have f of x is equal to 5x to the cube minus 3x. So I'm going to replace all the x by negative x. So I'm going to have f of negative x is equal to 5 times negative x to the cube minus 3 times negative x. So I replace all the x by negative x. So if negative x raised to the third power, you're going to have negative. So it's going to be negative 5x to the cube. Negative times negative is positive 3x. Next step, I'm going to factor out negative 1 or negative. So I have 5x to the cube minus 3x. But this one is just f of x. It's f of x. So I have negative f of x. So basically, f of negative x is equal to negative f of x. That is odd function. Let's look at the next example. I have f of x is equal to 2x to the fourth plus 4. Again, I'm going to replace all x by negative x. So I'm going to have f of negative x is going to equal to 2 times negative x to the fourth plus 4. Because negative x raised to an even power, you're going to have positive. So it's going to be 2x to the fourth. This is going to be equal to that. So it plus 4. But this is f of x. So I have f of negative x is equal to f of x, which is an even function. Let's look at our next section, the library of function. So they want you to graph this. F of x equal to x. If x is greater than or equal to 2, f of x is equal to 2 if x less than 2. So you have a point here, 2. When it's less than 2, f of x, so f of x is your y. X is over here. So when x is less than 2, f of x is equal to 2. So 2 is over here. Let's say 2 is over here, 1, 2. So if it's less than 2, I'm just going to put open circle here. Less than 2, go to my left. F of x is 2. So it looks something like this. Alright? So I'm just doing this part. Now if it's greater than or equal to 2, so greater than or equal to 2 is go to my right. Greater than or equal to 2, so you can circle it. So if x is greater than or equal to 2, f of x equal to x. So when x is 2, f of x will be 2. When x is 3, f of x will be 3. X is 4, f of x will be 4. So basically you're going to have a line. Right? So you're going to have this graph horizontal and then going up. Right? Next one, they want you to write a linear function. Linear function f, that f of 0 equal to 1, f of negative 1 equal to 0. So I'm going to put in a coordinate. F of 0 equal to 1, it means when x is 0, y is 1. Right? That's what it means. Now when x is negative 1, y is 0. I get it from here. So basically I have 2 points. I have 2 points. I can find linear equation. You can use slope y-intercept or slope point-intercept. Either way, you need to find slope. Slope is y2 minus y1 over x2 minus x1. Alright, so let's call this y2. So I'm going to have 1 minus 0 over x2, which is 0. Let's see, y2 minus y1, x2 minus x1, which is minus 1. Then I'm going to have 1 over 1, which is 1. So my slope is 1. And 0, 1 is the y-intercept because y-intercept x is 0. So I'm going to use slope y-intercept. So y equal to 1, x plus b. This is my b. So y equal to x plus 1. If you're going to use 2 point and slope, you can do that too. You're going to get the same thing. This is just easier. Alright, see you next time.